Hi everyone, welcome to a new lab session 9, which is based on advanced BIOS interrupts for display. So in this lab session, we're just going to pick up the basic concepts which we studied last time and we're going to build upon that. And particularly, we'll be looking more into the nature of graphing or how the graphs and displays are drawn. That is what it is. So let's proceed. So this is a quick revision of BIOS interrupt 10H. So we last time saw that there are four main aspects to video display, which is setting an appropriate video mode and reading slash setting the cursor position, reading, writing an ASCII character at a given position. So what we'll work on today is something very similar to this, but it is not like people very often get confused. They think that writing an ASCII character is same as doing graphing or putting out on display. What we're going on work to do is working at the pixel level on the screen, example drawing a line square on the screen, etc. All right, so this was just what we had attempted last time. Write your name at cursor position in blue blinking text with a black background. All right, so the first task is filling up a pixel. So filling up a pixel. So all these resolutions which you see. So if you notice here, I have not drawn this right now, but here there is a red dot which you can see here. All right. So this is corresponding to the pixel which we want to draw. So how does that happen? There are four things which we have to specify: AH, AL, CX, and DX. So CX and DX contains the column and the row respectively. So here you can see 10, 20. So 10, 20 means that row number is 10 and sorry, column number is 10 and row is 20. So these are your rows. This direction is your rows and this direction is your column. So here the distance is 10 and here the distance is 20. All right, so this is CX is your column and this is your row. So but before doing that, you have to first of all set the graphic video mode on before attempting to fill in the pixels and everything, right? And this is based on the resolution. As you can see that this is based on the resolution. So and the content which you want to put, the color of the pixel which you want to put, that you can specify from here. So here it is 1100, which is corresponding to the red. All right, so let's execute this quickly and obviously we'll put a blocking function because we want, until unless we press any other external button, the pixel should remain on the screen. So let's open the DOS box now, and this is my DOS box. Open the VS Code. So week9 c1.asm. So what we'll do is first of all set the graphics video mode on and then fill in these pixels, and finally we'll do the blocking thing. All right, so I'll save this, and in the DOS box I'll do ml week 9 c1.asm. So it got compiled into c1.com. So debugx week9 c1.com. Okay. So as you can see, the operations, you can do one-to-one correspondence, and we have to execute our uh, instructions till the address 011A. All right, 011A. So it will be G011A. So now you can see that a small pixel has appeared here. All right. Now the next step would be, like, you have put one single pixel using this. Now if I do this in a loop operation and keep on increasing the CX and keep on increasing the DX in in a pattern manner, then I can draw different shapes. All right. So that we'll do in this next topic. Follow along example. So first of all, see, write an LP to print a white square of pixels. So here is how the square should look like. I've drawn the video. There is a video playing here. So you see that I'm executing till 015e where till my code is, and a white square of size of pixels 400 cross 400 is printed starting from pixel 10 comma 10. Okay, so that is what we want to do. So how to go about doing that? As we have seen that we know how to print a single pixel, we'll do the rest of the operation. So set display mode to 640 cross 480 using first of all your 12 edge statement. Okay, and then the set we'll set the cursor position. Now setting the cursor position is for the final printing of ASCII characters, which was the point number 3 as I was talking about. Okay, reading, writing, and ASCII character. So once the program exists, from where the cursor position is, or where things will come like program terminated, or where the registers will get printed. That cursor position is I'm specifying so that when the program exits, it should come there. All right, so just for a graceful exit. So I'm setting that to 25 comma 25, which is like in if you it, this is broken into 40 cross 25. So somewhere towards the bottom side, I would like to print this. And for doing that, I know in my h I have to put 0 to h, and dh comma dl will specify. So I've right now here mentioned 20 comma 20. So either you can change this to 25 25 or whatever it is. It does not matter. And then initialize parameters for box drawing. So this is a step which you will understand more later, that how am I actually printing that single pixel and taking it forward or taking it backward or taking it to a particular direction. All right. So for that we need the row starting address, the row ending address, the column starting address, and the column ending address. So something like this, that these are basically the coordinates: 10 comma 10, 410 uh, comma 10. Sorry, this is 10 comma 400. So 10 comma 410. Then this is 410 comma 10, and row in the row comma column format, and this is 410 comma 410. Okay, so here also I've made a mistake, so it should be 410. Like while doing the screenshot, I was trying something else. And the count, you can ignore this as of now, it's not that important. So just for painting the white box, this is the code which we'll be using. So to paint the box, we'll just keep a note of the addresses SA and DI, right? Okay, what are these containing exactly? So we want to print the white background. So AL, what is going to be printed, the pixel color is set by AL. The operation itself is going to be told by 0ch, as we had seen in the last example of a single pixel printing, that it is 0ch. In AH we put 0ch, and 0ch. Then column, I'm putting di, so this is column, and this is my row. So what I'll do is, if I have to print now in 10h, will print at the si comma di, right? So what I have to do is, if you consider this as one, one whole set of things, then in my di I want to put the column ending address. I want to print it from this direction. Okay, so here it is getting printed this way. Now the row will change, and again the column ending will address will get. You have multiple ways to do that, so this is just one of the ways. So do not get confused why am I doing it this way. And since their pixels are so close, that it will all appear like continuum, so it will all appear like a continuum. So one thing which I'm doing is, I'm setting my di, I'm moving my di, in my di I'm moving column ending address cx. All right, and in my si I have the row starting address. So if this is 10, so it will begin with 10. Then once all the columns in this row are printed, it will move on to the next row, which will be 11, and this way it will continue all the way up to 410. Okay, so but after each and every printing of row, after each and every printing of row, I want to check after printing each pixel, I want to check whether I've completed the all the columns in the row or not. So for that, I'll push in cx. uh, I'll push cx, and I'll pop the cx, because during these operations cx might change, right? So whatever is my column ending address and the current column, I'm storing that in the cx. So I'm popping that out here, and I'm comparing that with the column start. So whether my current cx is pointing to the column start or not, basically whether cx is reached 10 or not. if it has reached if it is not reached 10, then I will continue with this operation of printing in the column. But if it has reached, what I'll do is I'll increment the si, basically si which it was pointing here, it will start pointing to the next row. And then I will move in ax the row ending address, whatever the row end is, and I'll compare si with ax, trying to find out whether si has reached this column ending address or row ending address or not. If it has reached, then I'll exit the program. If it is not reached, then I'll again, you know start it from the column 1, this side, column 1. From here, I'll start to print the next column. All right, the next row starting with this column. So this is how this code is written, and this is the blocking function which we've seen, and this is the termination function. All right, so let's see this in action. C3.asm. So there can be multiple ways of printing. This is just one of the ways which I've chosen. Might not be the best way, okay, but if you have a simpler code, you can push that into the repository. You can do a pull request, and you can submit it in the GitHub, and I'll include it in my repo so that others can also see. All right. So I'll save this code c3.asm, and so what I'll do is now compile the code. Um, I don't see this as the correct thing. Okay, this is not picking up the right thing. Just let me save it once more. Okay, this is the right thing only, right? So I have to look for AH4C. So I want to print it till this point where dot exit is. So picking up 015E. So G015E. So here the box got printed, and as soon as I press the percentage sign, the program terminated. And then I had put my cursor at the position 25, 25. So that's why it just got the printing happened here. If I would have changed it to, let's say, something like 10 comma 10, okay, and I execute this once again. So you have to play around with this, try reducing, changing tweaking the parameters of row string row and column string column end, and see how it is working out for you. So G015E. If I press the percentage sign now, notice that this is the 10th column, in the 10th row it has appeared. All right. So the cursor position was here, but intrinsically it is doing a carriage return, so therefore it is jumping onto the next line while it is printing. So that is our second example. Now we'll print something complicated. Now it's not like I'm not doing anything magic or anything. It's like just picking up those basic simple concepts and trying to make some patterns. All right, so let's just watch the video that how this pattern will be drawn. So first the white, then this pink color box, then again white, then whole thing pink, white, pink, white. So do not, be so crazy minded that uh, like some people I see that in my like in our time also they wanted to print first white for these many times, and then they wrote a algorithm like printing white and then printing this pink thing. So that is not the correct way of doing that. All right, so I was talking about that many people try to do it in a very convoluted manner, but yeah, making a pattern is not about. Matlab, you can do that in a convoluted manner. There is an algorithm which you can write, but it will be crazy complex, right? So a simpler way is that you already know how to print boxes now. Okay, so try to build on modular design. You already know how to print boxes. So first, print a box, a white box here. Okay, now this next step would be to change the vertices and whatever your column start, column ending, address, everything is there. Change those addresses and print a this pinkish box. Okay, and the next step would be to print a white box. So how many times you have to repeat this operation? So 1, 2, 3, 4, 5, 6, 7. 7 times if you repeat the if you repeat making of boxes, you will obtain this pattern. So it's not difficult. If you see any new pattern, you should be able to correlate with what you've already learned and what you've seen, and things would be simpler. Okay, so let's see the code for this. So as always, the first is to set the display mode, and which we do it via this code. Then setting the cursor position so that when we exit, it comes out gracefully. So here 2020, I'm not sure whether it will get printed there. We can tweak this thing anytime we want. Then initialize parameters for box drawing. So this is the same thing, the original code which we had, and this time just by looking at the the size of the boxes, I was able to figure out that the first white box which you see here in the question, it might be it will be mentioned that okay, this is 400 cross 200 with the starting vertex as 10 comma 10 or whatever it is, and then you will be able to figure out okay, with what size you have to reduce each time you have to reduce the box size to what size the resolution is. That will also be mentioned in the question. As of now, just a typical example, so I've not done that part. So this code we are clear with painting the first box. So paint one, we are painting this whole box with the starting row start, column end, and doing all the operations for printing out the first white box. Okay, so this is the white box. We've seen the code for this in the previous example. The next thing which you have to do is change vertices of the box. So let me just paste the code here itself. Okay, so I've pasted the code here itself that for changing the vertices from the next box for the next box. So now we have to draw the next box which is of pinkish color, right? For that, the row end in the question, it will be mentioned that okay, from for how much resolution you have to decrease this. So in this question it is mentioned that decrease each time you print, decrease both sides by 10. Basically give a margin of 10 on all sides of 10 pixels. So that is why on the variables row starting, row ending, column starting, column ending, we'll add or subtract this number 10. And for doing the operation, as we had discussed in the last lab session, that it has to be a word pointer. It has to, because it's 16 bits, so it has to be a word pointer thing, which we have to increment by by 10, add by 10. Okay. So what we're doing is we're loading the row string into SI, and then whatever is stored at the row string, we're incrementing it by doing the add operation. And this subtract, add, subtract. So every row string and column string are added by 10, and row ending and column ending are subtracted by 10 respectively. And we increment we load the count into SI and then increment the count value, because you have to check whether it has finally got terminated or not. So check if the counter has reached 7. So after we've printed one box, we'll increment the count, and we'll check whether the count has reached 7 or not. So compare, like in BL we're moving count, and in EL we have 0, 7. So next what we have to do is compare if it is greater than or equal to, then we can simply terminate if count is greater than or equal to 7. Okay. So program will just exit. If it is not, it will go on to the next part and print the next box. So the code for that is simple. It is the exact same code which we have written this time, which we had written previously. Only thing is that these here it is column one, the placeholders, like where you have to jump, those things will be replaced, or else it will throw it back to the previous loop. So column 2, row 2, and only thing we have to change here is this. Rest of the code will remain the same. Obviously we'll have to change the color of the box of the pixels which you're printing. So for that, 1100. Okay. So next what we have to do is once it is printed, that again we'll copy the same code which we have done earlier. We'll change the vertex and we'll increase the count by 1. And if the count has reached more than 7, we'll delete, we'll terminate the program. So that is it. Let me just show you once on how we execute this. So this is the code which is uploaded onto the GitHub. I'm just saving onto this, and so ML week 9 C2.asm debugx week 9 C2.com. So let's see where our address is terminating. So I look for a place where AH4C in 21H is repeating 2 times. So here I see that my code is ending at 01D4. So what I'll do is G01D4. All right. So now the program terminated normally. If I wanted that this thing printed here, then I can change the cursor position. It will print it below this. Okay. So you can try that out, and that's it for this video. Your next task would be to perform your lab tasks. Uh, so thank you for your time. See you in the next lab session.